the frame of the shaker system. So the bearing diameters on the shaft got wore down, undersized, way wore down, and the guy was having failures. He tried to just put new bearings in and do some welding or a lot of different little things that people think they can get away with to make things go, but it turned out the thing would not go. So we're doing a complete repair on the shaft. We're making 2 new bearing retainers, and we're fixing the frame plates. You can see that this one end is partially turned. I had welded it up. You can see some weld there. I've got a dial indicator on a surface that I didn't weld that I'm using as a reference point. And then here we're going down the whole shaft. This piece in the center, I cut a piece of pipe to the outside diameter on the inside of it of this shaft, and then I turn the outside. Later we'll machine that again in the lathe that we're going to finally do the machining on to finish these diameters. Right now I'm just facing off. I just put this in the lathe, and I'm supporting it on my steady rest on those good diameters because I wanted to remachine the center holes so that when I bring it to my other lathe, I can use a center, and that'll hold the piece up and it'll run true according to that diameter that I'm rolling the steady rest on, and also having had indicated from on the other side. So anyway, there's the whole works going around and around. We're turning it pretty slow because, for obvious reasons, if we turned it up to about 500 RPMs, the lathe would probably fly over, or something would break and fall out, break out and fly out. So this is my Victor lathe. It's not a heavy duty lathe, it's a medium duty lathe, and we're looking way down there. I'm going to turn it off for a second. And there's another view. It's going to finally be finished in this lathe over here. This is our Springfield lathe, heavy duty. It's just got enough length that we could put the piece in here and do the machining. So I've got a steady rest that I'll probably just leave the top off. And then after we put this thing between centers, we'll take a cut on that center ring that I have welded on that piece we just saw over there. And then it'll just kind of roll here to help to just kind of support it, maybe dampen vibration a little bit, who knows. Or maybe I'll put the top on too, keep it from flying out if I try to kick the RPM up a little bit. So here's the tailstock on this big lathe. It's got a number 6 Morse taper, and there's a live center in there. What other kind of action is going on in this shop? Well, remember our boring mill. It's still not completed. We have to do some maintenance to get it up a little bit better in order. Here's part of a power hacksaw here, and a small pump that the power hacksaw, as the system is rotating a shaft, it cams a pump, I guess you might say, rod back and forth and supplies fluid to a hydraulic unit that brings the thing down under pressure. And there's part of my hydraulic press that also needs repairs. Got a 30-ton hydraulic press, and there's the rod. The seal is bad. I need to get higher pressure seals. I'm going to make new pistons and new rods for these. Here we have our truck is for maintenance. We're going to do brakes. I had the rotors in the lathe. I re-machined the rotors. Got a nice clean surface. They had enough on them we could do that. There's our GMC Sierra. We've been driving our Chevy lately. There's our horizontal K&T milling machine. Antioch milling machine. There's the Lagoon milling machine. Here's a Cincinnati, is it? Yeah, Cincinnati vertical milling machine. Got a little lathe back there. Bridgeport's over there too. CNC lathe. There's a grinder hiding back there, cabinets, vertical bandsaw, a dinosaur forklift that works and does the job. Big scissor lift. I'm finishing the electrical on the inside here. And once more we'll spin around and show you everything, and that's it.